routing. So I'm going to go back here to the ISP router. And the ISP router on its gigabit Ethernet 01. So fast Ethernet 01. Its IP address is 204.184.21.33. And that is a...
Is that 184?
Yeah, it's the exact same. If you look on your lab, it's the exact same thing on your lab. I'm not changing anything. So that mask is /3. You turn the interface on. Now, I don't have an outside connection for the ISP, and that's okay. You can create one if you want to do testing later on of your ACLs and your NAT and all that good stuff. We'll get into that next week. All right, so who sees a problem there? What am I missing that most of you missed on lab 2? Yeah.
The server's password protection?
Yeah, right, good job. Simulator. Service. Password encryption. Wow. I just got a point. Okay? And I'm going to put the ISP router aside real quick. I need to change this connection because otherwise it's not going to come up. Connections. I'll erase it. I just clicked on it and hit escape. I actually need to make this a crossover cable between the routers. So F01200. Alright. And then on R1, I need to do the IP addressing for its interfaces because we did not do that last time. So int F0/0 as an IP address of 204.184.21.3/30. Keep hitting 355, my bad. And turn it on. Alright. Test that out. Ping the other side. Make sure I put the right IP address on there. I did that last night. Close on, I got it right.
You put 34 on R1 and then 33 on ISP.
Yeah, that's right.
Oh,
I have it right. Ping. There it goes. Okay. So then the other interface on R1, fast Ethernet 00. I'm sorry, 01. Its IP address is 204.184.21. .29. And that's the slash. On. Okay. 194.21.30. That looks right. And the other side, there we go. We have connectivity. So I have connectivity, so I'm good. Now, all things considered. All things considered. So I've gotten number 1 done. I've gotten all the host names on. I've got number 2 done. I've gotten all the IP addressing done. Everybody agree? Anybody have any questions on that? Disagree? Oh, you missed something, Professor Brown? Okay, cool. Number 3. Now we got to put routing in. Now, since we're not using any type of a routing protocol, we've got to use static routes, right? So, you can do this from the inside to the outside to the inside. It doesn't matter. Pick one and go in that direction. Okay, it's the easiest way to do it. So, I did inside to outside last night. I'll do the same thing. So, on the firewall, for extra credit, you've answered already. You don't get to answer again. All right. How many static routes do I need? Now, ask me this to do the static route because it's different on the ASA. I'll get to that. Just the number. How many static routes do I need on the ASA? Look at that diagram right there. Okay? There's my ASA. How many static routes do I need? Where do I need to go? Where do you think most of the traffic is going to go? Remember, routing is done on a destination basis. Packet comes into a device. The routing device and an ASA is a security appliance will act as a router. It looks at the source IP address, or does it look at the destination IP address for routing? Not filtering, not natting, routing. Which one does it look at? Source or destination? And the IP header. Think about this, guys. Packet comes into device. Says, I want to think about mail. Mail goes in the mailbox. Mailman picks it up. Goes to the post office. Huh? Destination. 3?
Because if it goes that way.
Because I got three connections on it.
Well,
Is that what you're thinking?
It's coming to an ASA. Well, it's coming to it. Wouldn't it be 2? Right?
2? No.
1.
You already answered though, didn't you?
I didn't answer.
Okay, good. Seeing that class. 1. Now, do you know what type of a router it would be? You're right. You're right. What type of a route would it be? What type of a static route would it be?
Default static route?
Default static route. Come see me. You already answered one already. That's cool. Come see me in class. A default static route. So, one back here. On the ASA, I want to put a static route in. First off, I got to go into configuration mode, global configuration mode, just like router. Okay. Now, in a router, I would put IP route, right? This is a little bit different on an ASA. It's more or less the same syntax as in a Linux server. Okay? If you've ever taken Linux or know a little bit about Linux. All right? So in Linux, to set up a static route command, you use the command route. Then you have to tell, well, where's my exit door? Which interface am I leaving? Okay? So for a default static route, I don't have to worry about the inside network. I don't have to worry about the 10 network. I don't have to worry about the 192 network. They're connected. I know them already. So if a packet came in from the inside network and needed to go to the DMZ network, I already have that in my routing table because I have an IP address of that network already, so I don't worry about that. I don't need to route that. But if a packet came in with a destination of a public IP to say Google, I don't know where the heck that is. All right? So I have to route that packet, and I have to tell it, well, what interface am I leaving? I'm going to leave the outside interface. Okay? So route outside. Then your network and mask, for a default route, is always what? All zeros. And then just like a IP route statement, what's the last thing in the IP route statement? Your next gateway, your next hop. In this case, it would be the IP address of R1's F01 interface, which would be 204.184.21.29. Because that's this interface right here. All right. So one, there. All right. Back to the diagram. Okay. So that took care of R01. Now, here's the trick question. Let's look at R1. That's our next hop. How many static routes does R1 need to have? This is a trick question. So you'll think one thing, it's actually only something else. How many static routes does R1 have to have? No idea?
None?
None?
2.
Packet gets to R1, it has a destination in Google. How's it going to know where to send it?
Oh, okay.
So that's a clue. It needs a default route too, right? Okay, so we got that, that's easy. That goes out to the ISP route. All right. Now, what other networks does it not know about in this diagram? The inside network, and what other one? The DMZ network. So you would think that it would need 3 static routes, right? Why is that wrong? Here's where you get extra credit. Why is that wrong? Why would I not want to tell R1 about one of those networks, the inside network or the DMZ network?
Is it for security reasons?
Yep.
So you don't want someone to be able to know that you have them. And you say,
Why would I want to route to a private network from a public device? Okay? Think about this. Traffic, what you would think, well, traffic coming back, it has to know its destination, right? It has to know about this network. What doesn't get routed on the internet? RFC 1918 networks, right? This is an internet router. Why is it an internet router? It's all public IP. Traffic going out, when it gets to here, if you look on question, I think 7 or 8, not sure which one. I'm sorry. 7 or 8 or number 10. Down there, Liz. I'm sorry, it's even before that. Question 5 and 6. Go over that. Okay? It's gonna pat, right? It's gonna get, the workstations down here are gonna get translated to this IP address, 134.68, I'm sorry, 204.184.21.30. Okay, so R1 and the ISP don't need to know about this network. They don't. So you only need 2 static routes. On R1, you need a default route out to the internet and you need a route to know how to get to this network. Not the 192 network, because that's a private network too. All your natting is going to be done on the firewall, and that's your network. That makes sense to everybody? Okay. So on R1,
That's the screen.
thank you. I'll do that like 5 more times. I promise you. R1. IP route, let's do the default route first, all zeros. It should look familiar from lab 2. Your next hop is the ISP IP, which is 204.184.21.33. Okay? You see that all right? Cool. And then I need to make a route to the 134.68.123 network and point its next hop to the outside address of the firewall. IP route 134.68.123.0 /29/26 IP, sorry. 255.255.255.192. And the next hop is the IP address of the firewall, which is 204.184.21.30. Everybody see what I've done there? Does everybody understand what I've done there? That is so that packets, when they come into R1 from the outside world, know how to get to that 134 network. If I don't put that there, that's going to break the chain. It's going to break the highway, crush the bridge, whatever you want to call it. Okay. Last but not least, the ISP. Now, for the ISP, all right, little caveat here. All right, we're going to assume that the ISP is managed. We don't have to worry about a default route. That's just magic that happens somewhere. But we need to tell the ISP, let's say we have like joint administrative rights on this router, about the networks that are below it. All right? And there are only 2 networks it really needs to know about. Okay? It needs to know about this network between R1 and the firewall, and it needs to know about the public IP network of the DMZ. Does not need to know about this inside network. Now, you probably ask yourself, well, why does it need to know about this network here? Anybody? Why would it need to know about the network between R1 and the firewall? What did I just explain that we're going to go over tonight? That's going to happen in order for that private 10 network to get to the internet. That IP address right here, .30, that's your PAT. Therefore, the ISP network, which will advertise these networks to the rest of the world, has to know about it. Does that make sense? I see some of you shaking your head, that's good. Okay? So on the ISP router, we have to tell it that 204.184.21.28/30 network and the 134.68.123.0/26 network exist. We do that with 2 static routes. IP route. See, thank you. Told you, man, I got my bell rung tonight. I'm not thinking straight. I'm on the ISP router, doing a static route. IP route 204.184.21.28 as a /30. 52 is your last octet. The next hop is the outside IP of R1. 204.184.21.34. Everybody see that? And likewise, I have to tell it about the network that's on the DMZ. Now, I'm not telling it about the 192.168 network, because all those hosts, all those servers are going to get added to that 134.68, 123 network. Okay, so that's what I got to route to, because the traffic is going to be natted. IP route, sorry. IP route 134.68.123.0/26. 192 is your last octet. And the next hop is the same as before. It's the IP address of R1. 204.184.21.34. Okay? And that is all you have to do as far as routing is concerned. So that takes you through 1, 2, and 3. Number 4, again, that's your RFC 1918 ACL that you're applying on R1. You've done that in Lab 2. You guys should be able to get that one. So for Lab 2. Okay, most of you got that one right. So 5 and 6 is where we have to set up NAT. Alright? And what we're going to do is, and it's a little hard to see here, I know, I apologize. Okay? The local IPs, which are the physical addresses, are going to get natted to a public IP on that firewall. So the easiest way to do that is to set up a network object. A network object. We talked about that in the lecture a little bit last week. Okay? Firewall. Or a couple weeks ago, excuse me. So, here's what we got to do on the firewall. This is a new command. And keep me honest tonight. Thank you. Alright, so, if I remember this correctly, it is object. Object network, and then you give it a unique name. Okay? I don't care what name you give it, but here's a little bit of a helpful clue. Alright? If you look at the diagram, it says server, web, mail, FTP, DNS. It's a good clue for you. Okay? Make sense? Kind of make it something that you can recognize as to what its job function is. Just don't call it like Kyle or Cartman or Sulu or Kirk or Luke or whatever, right? Or we can go the whole Game of Thrones route as well, right? Don't do that, okay? Nobody should be reading your configs anyway. The only reason you should be reading your configs is if you're troubleshooting, all right? And the thing that I hate to do when I'm doing an audit or I'm doing troubleshooting is when I come to a network object and I don't know what in the hell Cartman is. Make sense? So, let's talk about the first one. It was called web. All right? And I name it. Now my cursor changes to object. Here's where I put the IP address in. Now I can make this an entire network. I can make it a NAT. I actually need to tell it what the host IP address is. In this case, the local IP address. the local IP address. Okay, so I'm going to type in host. All right, and then its IP address, which for the web server is 192.168.0.13. That's on your diagram. Okay, that's it. Hit enter. All right. Now I want to translate it to a public IP. What do you think I have to type next? Anybody want to take a guess because it's up on the board? NAT. Come see me after class. All right. Now I do an open paren. All right. Okay. Now I have to tell it what interface it is coming from. Okay, it's local, which is going to be DMZ. I put a comma, there's no spaces here, and then tell it what network it is going to, in this case, the outside. Close the paren. This is a static. All of these NAT statements are going to be static. And then it's mapped IP address. It's public IP. It's public IP. Which in this case, on that diagram, is 134.68.123.13. And I hit enter. Okay. Show run. You're going to see two things that show up. You're going to see the network object, which is its IP address, and then you're going to see an object network web. Again, this is where the translation happens. Okay, we got that. No? What, Brent?
190, what is it? 134.
I went straight off the table that is on the lab. I did not deviate. So I did the web server. Okay? I tell you what, I'll do the mail server as well because this NAT stuff is a little challenging. So let's do the mail server too. Go back to the global configuration mode. We'll go a little faster this time, guys. Alright? Object. Network. I'm going to name this one mail, because it's for the mail server. Host. Its private IP address, its actual IP address. 192.168.0.21. Enter. I now need to set up its NAT translation. So I use the command NAT. From the local network, which is the DMZ, comma, to the global network, which is outside, and then it's public IP address. 134.68. .0.21.
Isn't it 168? Static.
Well, status though.
Thank you.
Okay. Now I have two objects. But they're translations. Okay. Everybody follow along. Okay. Now, here's the tricky part. You got to remember. All right. You're going from interface to interface, DMZ to outside. You also have to do DMZ to inside as well. You want connectivity to these devices. Okay? But it's not going to be the same. And here's why. You don't want to put public IP to private IP translation from a semi-autonomous network, i.e. your DMZ, to your private network. You're going to go private IP to private IP. Okay? You've already created the network object for the private IP. That's totally cool. So all you have to do is go back into those network objects and create a second network translation from the DMZ to the inside. In actuality, always go from higher security level to lower security level. So instead of going from DMZ to outside like we did this time, it was going to be from inside to DMZ. Inside to DMZ. All right? So I will do, let me do the web server for you. Conf T, you go back into the object, network, web, okay? NAT, in this case it's going to be inside, comma, that's what inside, right? Comma, DMZ. All right, and its IP address is going to be the exact same as its physical. So 192.168.0.13. Ah, gotta do static, sorry. Keep forgetting that static. Whoops. You know what? I goofed. Disregard what I just said. My bad. Disregard what I just said. Getting ahead of myself. Yeah. You only have one NAT state, one static NAT statement. Okay? That's fine, that'll work. All right. Now, the next piece here, if you look on your lab, question number 6. Okay? Disregard what I did that last thing. I apologize. I goofed. Create an overload PAT address that is tied to your firewall's outside interface and allow the workstation subnet to use it. Okay? So I need to create a network object for the inside network. For the inside network. The whole inside network. All right? Object, network, name it inside. Okay? Now instead of doing host, because we're not doing one single IP, we're going to do an entire subnet. So we do subnet. And 10.0.0.0. And subnet mask, which is class C, 55.55.55.0. So same thing, object network, named it inside, like what it is. And then instead of host, we use subnet to identify the actual subnet. Okay? Now we're going to take that object and put it through a dynamic translation, to leverage path. Okay? So we're still in the object group. So this time, we're still going to use nat. Open paren. We're going from the inside to the outside. But this time it's dynamic, it's not static. Okay? And we're going to use the interface address as the mapped IP. Okay, which is going to be the IP address of the outside interface on VLAN 2. Okay. Yeah. I missed something. Hold on. I missed something. No, I'm gonna tell you right. Since it's doing it, it's gonna overload automatically. Yeah, that's right. It will overload automatically. I keep forgetting I'm using a newer version of code. I'm using the old version of code, which is a little bit different. So that's what you need from Pat. 7, 2 more to go. So 7's really easy. All right, you actually had it in there initially. We took all the DHCPD out. So it's just a DHCPD command to set up your DHCP server. All right. So we're going to do a DHCP pool for the inside interface. We're going to set up the DNS server as 42222. And we're going to ensure that the inside interface 10001 is the default gateway. Okay? Here's how we do that. You use the DHCPD command. Okay? Let's go ahead and do the address first. Configure the IP pool address range. Alright. So we do this from the start to the finish. Now, looking at your diagram, we don't do reservations like we did in routers. So we have one address here that's reserved, which is our AD, which is .10. And our gateway is going to be reserved as well. So I don't care how many addresses you do, or does it tell you how many you want once done here? I don't think it really does. No, it doesn't. So what I would suggest here is, we reserve the first 10 addresses and put the rest of it in the DHCP scope. All right, so 11 through 254. So DHCPD address 10.0.0.11 to 10.0.0.254. And you have to tell it, well, which interface it is going to get tied to. So it's the inside interface, it's the inside network. All right. Now the other thing that we have to do is we got to set up the DNS and the default gateway. So DHCPD. Okay. DNS, and then the IP address of the DNS server, 4.2.2.2. Interface. Now I have to tell it where to go look for DNS entries. So where do you think 4.2.2.2 is going to be? Is it going to be on the inside interface, the DMZ interface, or the outside interface? Where would I get to it from? The inside interface, the DMZ, or the outside interface? Where's it at? So it's a 134 address? Or a 192.168 address? No, the address is 4.2.2.2. That's weird. Outside, right? Somewhere out there in that magical place that we call the internet. So it'll be outside. Now, I actually don't think we can do I have to do enable. Inside. When we do that, that's going to make our inside network the gateway. Okay, so we have to do the DHCP enable on the inside interface, and that makes the interface the default gateway. So don't forget that one either. There's 3 commands you have to look at. So go back and look at this real quick from show run. Yeah, there's your 3 commands. DHCPD address 10.0.0.11 through 10.0.0.253, or 254, or whatever you want to make it inside. DHCPD enable inside. And DHCPD DNS 4.2.2.2 interface outside. That sets up number 7. Okay? And last thing we're going to do tonight is we're going to do number 8. So on number 8, all we got to do is set up a username, administrator with a password change me. Okay, don't ever set up a username admin with password change me. This is for instructional purposes only. Okay? I don't want you guys going out there into the workforce and saying, Professor Brown told us bad habits. He told us we could make administrator with password change me. No, don't do that. And then we're going to set up logging to go to 10.0.0.10, which is our AD server. Okay? Real easy. Easiest 10 points of the night, guys. Okay? So, from global configuration mode. Oh, and we not only have to do this, we got to do this on the routers as well. So we'll do that too. All right. So on the firewall, username, administrator was with the capital A. Now, that looks different from what we did in routers, isn't it? There's no privilege level, there's no anything like that, right? Okay? In there. We also didn't have to do service password encryption, did we? That's because the router does it automatically. At least it should. Or the firewall does it automatically, excuse me. Yep, there it is. It's encrypted. Boop. Alright. And to set up logging is just like a router, except you have to tell it what interface it's going out of. Uh-oh. Uh-oh. It doesn't have this command and packet tracer. Damn it. All right, fine. I can just do it on the routers. Okay, at least do it on R1. Logging, host, 10.0.0. Oh, wait a second. Who sees a problem here? Who sees a problem here?
R1 can't see that network.
Bingo! Bingo. This is why it's always good to read through the entire lab before you just start going boom, 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 boom. Okay? So, here's what I would do in this type of situation. Go ahead and set up your logging to 10.0.0.10. Okay? Logging host 10.0.0.10. Okay? Make a single static route to 10.0.0.10 from R1, but only from R1. Okay? Now, you also need to look and go at this from a standpoint of on R1, configure and apply an access control list that will prevent RFC 1918 networks from being sent out to the internet. Well, there's a problem too. So, there's a couple ways around this. There's a couple ways around this, guys. This is where you gotta think. I'm gonna make you think a little bit. Make your brain hurt. Okay? There's more than one right answer to get this logging set up. You can use the RFC 19 address. But if you do, then you've got to write your access list for number 4 a little different. And you've got to put the NAT in the firewall so that the outside sees 10.0.0.10. Or, what else do we have at our disposal? I have a /26 public IP, right? And I'm only using 1, 2, 3, 4, 5 of its addresses. I can steal an IP address out of that space from the firewall and NAT it to 10.0.0.10. There's one other thing you got to consider when you're doing this. I will review this on Monday. And please ask me questions on this because this is very, very, very specific. This is very specific. Security is not like routing and switching. It has much, much, much more moving parts. I have traffic coming from R1, sending syslog messages. First off, another 10 points here. Who can tell me, and who can Google fast enough, what is the protocol and port of syslog?
514 UDP.
Boom!
You didn't even Google that.
Damn, you know what? You get another 10 points just for on posterity.
I just set up a syslog server in CIS 200, so that's why.
Damn, nice. So, on the firewall, I'm sending traffic to my ACS on the syslog, UDP 514. What do I have to do as well? I do my NAT. I set it to say public IP. Or I set NAT to private IP. What else am I gonna have to remember to do? We haven't gotten to it yet. But what else do I, what other moving part do I have on a firewall that I have to consider for traffic? An ACL, right? So, in your ACL, for number 9, create an ACL for firewall 4. Remember, you've done all your NAT stuff. Allow SMTP and POP to the mail server. Allow BlackBerry services to from that server to the mail server. Allow web and secure HTTP from the internet to your web server. Allow access to your FTP server for anonymous FTP access. Allow DNS zone transfers from 4222 to your DNS server. Does it say diddly squid about syslog? No. But guess what? Because I asked you to set up syslog, you can't do it on your firewall because packet tracer's not letting you do it. You can set up syslog on a firewall. We'll skip over that. But because I asked you to set up logging from your router, it's going through your firewall. You've got to make sure that you do all the stuff that you're supposed to do to make sure that that traffic gets to that syslog server. Write that down, make a note, tie a string around your finger, I don't care. Remember that. If you don't do that, you will lose points. You've been forewarned. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We're still missing a good 12 people. Well, yeah.
Could you say that one more time, just
Sure.
in case?
I'll go over it another 5 times if you want me to. All right. Number 8. I'm having you send syslog messages from your router. Okay, R1. And logically, even the ISP router too. So I'm doing logging host, and I gotta send that somewhere. There's a couple of different ways you can set that up. Go back and redo your static routing to include that 10 network, or NAT 10.0.0.10 to a public IP in this scope that is not already being used. That's why we left this line here. Okay? When syslog traffic traverses from the ISP router or from the R1 router to the syslog server, it has to pass this firewall. And in order for the traffic to pass, it is going to go across an ACL that you are going to create in number 9. But in number 9, it does not tell you to allow syslog traffic outright. I'm telling you right now, those 5 steps, A, B, C, D, and E, you're going to have to do more. There's a F that you don't see. Yeah, there's an F that you don't see. Okay, it's hidden. Because it's implied from number 8. Does that make sense to everybody? So if I don't do it, when that syslog, when that UDP 514 traffic hits the ACL on the firewall's outside address, guess what's going to happen? It's going to get dropped, right? Makes sense? So if I don't put the entry in there, number 8's not going to work. You won't lose all your points, but you lose some of your points from number 8. Everybody got that? Does everybody understand? Okay? This is one of those things where security engineers, they've got to be on their toes, man. They've got to be really familiar with, how everything works, okay? And on a firewall or a firewall appliance, taking out VPN, it does 3 things. It filters, it translates, and it routes. It filters, it translates, and it routes. You've got to do those 3 things, okay? Unless it's in a specific mode, which we'll talk about next week in week 9. It only does 2, it filters and it translates. Okay? But in this mode, which we have everything in routed mode, it filters, it translates, and it routes. Cool? Alright, I think that's enough brain damage for one night. You guys have any questions? For those of you who got some extra points here, come see me. Let's get you some points for your labs or homework, or this or that or the other. And other than that, I will see you guys on Monday. Try to work a little bit on lab.